own up commits, then we want to perform that. That's the ultimate aim. So the first step is completely about separating the Jython APIs, and then the second option that we have is completely move away or remove that Jython or Jython scripts that we use inside the blueprints and migrate to Kotlin. Even that is also easy. Certain use cases I felt that Bell raised that issue. They had a tough time, but I really want to understand that what is the reason. Even I could provide the solution also easily move into that Kotlin in that case. Sometimes I may not aware of that use case also. We can look into that. What is the problem, real issue? Even Bell, they have that in terms of migrating to Kotlin. Okay, first let's look at first solution. The first solution is just separating out, which is easy for now, and then everyone can work keeping in their mind Kotlin. So once we get a time, then we can remove that. Let me jump into the code. If you try to look into that little bit, I will give that information about how this Jython framework is used. We have a blueprint. Inside the blueprint, we have a node. That node, it's a script node, basically the script node type we have. So we have three types right now. We have internal, Kotlin, and Jython. We have three flavors of a script to execute. Internal, it's completely about the API deployed along with or the scripts deployed along with the container. So it means like during the build process itself, we try to include the API or include that particular scripts part of that particular API, so that we don't want to deploy the scripts through our management API, through our blueprint management API. So it means like during the build itself, we try to build. So when we try to use this, okay, the question here is, we try to use that internals if you feel that it's a performance. You tested that blueprint thoroughly, and then you have a scripts completely, and then you don't want to waste time in production like booting or compilation, once again compiling it again and running in a separate thread, okay, and caching it, all kind of service. I don't want to use that. That particular script should be a part of that my Docker container itself. So in that case, you can still testing, you can use that particular script and then mark it like an internal, and then you can work, you can work like a blueprint, like a Kotlin. And once it is ready and once you test, and if you feel that there won't be any change going to apply on that particular script, then you can make it like a jar and then deploy part of the build, or part of the Docker image creation itself. So in that case, you can simply just changing over to internal. So you are not going to compile once again, and then you will get a better performance. And it's a really optimistic way to run. And the second scripting nature, it's a Kotlin. Kotlin is either through that CBA file. So it means like a more dynamic. So you can do your script in a blueprint, and then you can upload using our management API. And during that invocation, first it kicks off, it looks into the database and downloads from the database and places it in a file path. And then it invokes a compilation service. It compiles that API in a separate thread, and then it caches that particular jar file. And from next to subsequent request, you may get you can make use of that particular scripts. The real one disadvantage with it's like the startup time. It needs like some heating time. It's like during the first invocations, it tries to understand where it is and tries to compile and put it in cache. And for the second, you don't feel that difference between the first and the second. The first request feels the difference.
Brenda?
Yeah, go ahead.
Why do we not compile during the upload?
Yeah, because the problem is like the state of the container, it changes each and every time. So during that upload, the state of that application may be different, and during that invocation time, the state, it may be different. So that is the reason we don't want to make a chance. Why? Because there are so many cases where dynamic sources, dynamic dependencies will come into picture. So in that case, while uploading itself, it will have a different state. Okay, it is a matter of our decision. So whether we want
so we are missing dependencies for it, basically what you're saying.
Yeah, exactly. Sometimes. Okay, because we have a future use cases to include the dynamic dependencies also. So that is the reason why, because if you are trying to interact with the multiple scripts, okay, and multiple packages, if you are trying to interact with that, and after upload and during that invocation only, I can say or I can validate the entire scripts or entire blueprints, okay, it's a valid or not, because I want to be safe. Okay, I can spend some time on heat up time instead of failure. Okay, once I get a failure, I can't roll back. It's costly, right? So that is the reason you can make a decision. Either you can use during that upload the compilation cache or during that initial startup cache. I think I answered.
Okay, yes, thank you.
Yeah. So, and then second point, and coming back to the Jython, okay, it's a similar. Jython, it's I think you all know that, okay, but I will give a little introduction about that. It's a Python way of coding, but the actual runtime is Java. It is not really using a Python runtime actually. So you can write your code in a Python style, and you can use the JVM runtime. So that is a Jython here, and then 1.2.x version. And even Jython also, we had so many disadvantages in terms of performance. One is, I think you all know that, okay, performance perspective, and it is not a multi-threaded, and then it's a second important point is like you can't use that all Python API whatever we think. Okay, one good example, it's like a LXML. LXML we can't use it in Jython because Jython uses actual traditional Python uses a header, some C headers, which is not part of a JVM, which is not really a Python module. So it's like a C header module. So in that case, even inside that Python, we can't use a certain one good example. It's like a NC client. We can't use the NC client directly. Okay, inside the Jython. So that is the reason we came up with that wrapping of Java APIs as in a Python style, so that Python way of coding can make use of netconf API if you're running inside the JVM. So we have we want to give the taste of Python coding experience. That's the reason we introduced Jython, and even we have a lot of it's like constraints also. Like I mentioned that LXML, C headers, we can't use that all the APIs whatever we have it in Python dependency pip module, whatever the pip module that we have completely we can't make use of that. Okay, now we are in position how to. So in that case, we have a node. Node has a scripting. So we can decide that what kind of scripting that we want, and based on the scripting, it's like it is trying to invoke the corresponding service, whether it's a Kotlin service or it's a Jython service, Jython compilation and execution service. It kicks off and it executes based on our the direction what we put it in a blueprint for that particular function node. I pass it here to take some questions. If you have any questions, then we can discuss now. Yeah, before going into that. We are clear?
So I think I have a question. So you presented two ways of packaging the script. One which use the current way, which is fetch from the database and then compile and cache locally. And then you mentioned another one where you could be able to actually package them into the Docker image directly, right? With that, do you propose both ways so that we support both ways, or it's just we're gonna have to pick one or the other?
No, we can work on both ways, but it depends on how we build a Docker container, right? So if your assumption is like whatever the scripts that you're going to use are going to generate now, it is going to be a part of the Docker container, then you can use that. We can use both the ways. It is not the only option that we have. It depends on particular use case or particular script execution, whether it is internal or it's from the blueprint.
Okay.
You are trying to.
And this is for Kotlin script only, right?
Yeah, Kotlin scripts. Even okay. Java packages, Java functionality also. You can write in a Java function or a Java way, and then you can deploy as an API, and you can call with the internal. So the internal, it's nothing but Java class invocation. It is not a script that we develop and deploy during the runtime. During the build time, we develop and then we deploy along with that CDS itself.
Okay, so basically, this is a solution to having a specific pod to execute Kotlin script, the same way we have with PY executor, and take them out of the blueprint processor. Okay.
Exactly. So the idea here is just in a performance perspective. Another important use case is a performance perspective. I don't want to spend a lot of time in caching and then managing the threads and then deploying from the database. Okay, just I know that this is a component I'm going to deploy along with the Docker container. So in that case, okay, you can use the internal so that you can get all the advantages.
Okay, got it.
Okay. Any other questions?
So one
Yeah,
question.
Brinda. Yeah, here is Steve. You mentioned that there is some API from native Python that won't be possible to use in this Python executor. So I'm wondering if you give a way to import a library in your Python script, then use it in the runtime execution. Because I know that for the Jython,
Let me clarify before that. Okay, so we have two scripts actually. Okay, even the Python itself, we have a Jython and Python. Whatever I'm trying to talk about is a Jython. Jython, it runs along with the CDS. It runs in the CDS platform. And the Python script that we use, okay, specifically in case of a Python executor perspective, that is nothing but we are sharing the blueprints, and then Python framework or Python runtime will use that particular script, okay, as a separate microservice. The Python executor is nothing but it's a separate microservice which executes the Python, so that can execute any Python libraries, okay, if that particular module is installed or during that setup itself, if you try to install the pip module, then it can execute any modules because that is not a JVM, that is a Python environment. If we are planning to use the particular script in CDS environment, say for an example, right now we have a resource resolution, right? The resource resolution uses a Python. So we haven't created a Python execution runtime for resource resolution. So in that case, it is a JVM. So that is a Jython script. So that doesn't work with some of the pip module libraries such as LXML, NC clients, and REST. Okay. So with that assumption, okay, put your question.
Okay, so yes, hi, Samuel here. So maybe that was the answer you just said, but I'm particularly interested about the deprecation part. So,
okay,
what parts? You know, most of the scripts are Python, and people used to write Python a lot. So, what is the things with deprecate? So basically, the support for Python scripting is words will be decreasing, right? So you should write with Kotlin, because with the Python you cannot use the CDS, all the CDS utilities like the resolution you just said. But
yeah, exactly.
So that is the. So basically, it would be good to list all these negative parts also clearly somewhere, that what is dropped. So what support is dropped now?
Exactly. I will explain. Okay, so before that, let me explain that. Okay, just I want to give a little bit introduction about the Python executor also, so that at least some people know that, some people may not know that. So that's the reason I'm trying to give an introduction about Python executor. Okay, so if you try to look into that overall microservice, under the microservice folder, we have so many modules. One is a blueprint processor, one is a command executor, and controller blueprints, and PI executor, and SDC listener. Let me talk about the controller blueprint. It's nothing but the designing platform. Initially, before that, before LL2 release, we had two different microservices, one for designer and one for runtime. So after then, what we thought, it's like we will have a one microservice, and you can, during the deployment time or during that image creation time, you can flavor it whether it's a design time container or runtime container, because some of the functionalities needs to interchange between runtime as well as the design time. Mostly the processing time needs some of the designing capability, and some of the designer during that validation of the particular package needs runtime capability. So that is the reason we don't want to separate it out, and then we don't want to switch between containers. So during the build time, you can create either one. That's the reason we dropped that container support for controller blueprints. That's the reason we could see a modules here. And finally, the blueprint processor, it's going to decide. So you can have n instance of or n Docker images based on that particular. So one for design time, one for runtime, one for X services, one for Y services. Okay, you can create n number of instances or n images, Docker container images, and then you can spawn up. Okay, so I'm coming back to that. Other important concept, we have a command executor. So this is mostly it's contributed by Bell. So and the initial framework like a gRPC exposure and then initial design, I put that code for that. And most of the implementation like virtual environment setup and Ansible invocation done by Bell. So in this case, what's the thing? It's like it specifies a separate API. Okay, let me explain that particular API also. So this session is a little bit elaborative, so that now everyone should be clear what we are trying to do, so that we can fasten our process. That is the reason I'm trying to give a lot of information. So under the model catalog, we have a proto definition, and then proto definition this command executor, right? The command executor is exposed by an gRPC API, and that API definition is defined in the command executor. So you try to look into that. We have let me talk about this first. What is the purpose of this microservice? This microservice, it's like a separate controlled Python execution runtime. So it means like it's a Python runtime as a microservice. It doesn't have any of our CDS libraries. It completely works independently of the CDS as a separate microservice, so that in this case you can install any pip module or any Python module inside that code, inside that logic, and then you can write your own logic part of that CBA. So you can write a Python scripts. It is not a Jython, it is a Python script, and then those scripts will be executed by the command executor. So it's a pure Python, and it exposes multiple APIs. One is prepare env. Prepare env talks about installing what kind of pip modules that we want. Certain cases we may use a NC client. Certain cases we may not need a NC client. You may want to have a web scraping, screen scraping API. Sometimes I want a different version of screen scraping or NC client version itself. So in that case, you can spawn up or you can create a multiple images of a command executor based on your demand and based on your what kind of versions that you are trying to work on. And sometimes the VNF phone or vendor can provide the scripts to configure. So at that time you can containerize as a separate container, and then you can expose as the same service, same endpoints, whatever we have. So in that case, you can work in a controlled, secured, and a more manageable way. Okay, and even the scripting way. Network engineers can make use of that completely.
Yeah, so it's completely separate, and CDS provides only the distribution of that package in. Right. But so that is also disadvantage. So I mean, I would like to use the CDS capabilities. So
exactly.
Is there APIs to use those resolution?
Exactly. That's where we are coming. Okay. We can discuss about that also, how we want to make use of. Okay. So certain cases you may need that, certain cases you may not need that, because sometimes what's the thing is, it's like a task kind of or a remote execution or remote worker node. Maybe assume that in this case you want to act like a remote worker in your worker node only for Python execution. So in that case, I don't want to involve. So I will frame all the records, whatever needed for that worker, and then it can execute, and finally it can return back the response. So in that case, it is a more manageable and then more it's a more agile way that you can develop, and then it can be part of your framework itself. Okay, next we have a prepare environment. So in this case, it prepares that environment, what are all the packages that we want, and then after then we have another API called execute command. So execute command, it's like whatever the input that we are trying to pass, based on that command, it invokes the corresponding Python package, okay, from the multiple path, and then it executes a script, what script that we have, and return back the response. Okay, so if you try to look into that, it is not a streaming API, it is a simple request response. Okay, so you can make a request and then you can get a one response at the end. Okay, that's all about Python executor. So this case we are not deprecating. So it means like if you are going to use a command executor, okay, and what are the scripts that you are going to use inside the command executor, that is not going to deprecate. Clearly, it is not going to deprecate. Okay, so it is up to you. You can use Python scripts okay, like we do. Okay, one example. Let me show that how it is the model, right? Okay, so we have a.
Hello, Brenda. While you are looking for the model, I just have a question. I think there is a for me, I misunderstand the difference between the command executor and the Pi executor that
Okay,
that's
yeah.
kind
Let me
of
come to
new
that.
create. Yeah.
Yeah. Definitely, I will come to that point. Okay.
Thank you.
Yeah. Sure. Thank you. So here, this is so. Okay, let me talk about that where I left. Okay, so if we have a script, under the script we have a Python, right? So this Python, we have a script, and if all these scripts, okay, going to run it in a command executor, then there is no issues at all. So we are not going to duplicate. So it's still you can make use of it. I believe that is a bill. It's like most of the things they are using in this case. Okay, they are using a command executor just to execute all the command executions in a Python way, right? So we are not going to duplicate that. Okay, coming back to that now, what is Pi executor now? Definitely there is a need for some, during that initial design, it's like I was in vacation and then I could not concentrate much, so that I just exposed only that API and then definitions, and then most of the contribution done by Bill, right? So that's the reason even inside our AT&T or inside other organization also, many people are not interested or not looking for that immediately not looking for the Pi executor kind of thing. After then, what's the thing is inside that AT&T we had a use case. Okay, we had a use case. One use case that we have, it's like we want to have a continuous streams of what it is happening inside the remote execution, because we put that design in more in terms of reactiveness and what is happening inside that. Okay, that we want to understand that. Okay, so since it is a long running process, the Pi executor, it's a long running process. It may take a huge amount of time, so it means like it can manage a network transactions. Okay, it can work with the device directly, and then sometimes it wants to notify that response or notify the intermediate status to that caller. So those kind of functionalities we got that requirement. So it means like only one option that we had, it's like whether we want to go and modify the command executor to support that bidirectional streaming process, okay, or else we can create another microservice which satisfies the streaming process, right? You understand that, what is it? But the final end goal is the same. End goal is like to execute a Python, okay, but the difference, it's like one, I want to get a streaming response what it is happening right now. The command executor has some disadvantage in terms of returning that intermediate response, like a logs or notification. Okay, just it executes completely and finally it returns the response with the log status, only the log status, and sometimes we can't share the data between client and server, okay, who are the caller. That's where, so one thing, it's like just we want to modify the command executor, or we want to look in a different microservice. Anyhow, it's like we are in a microservice paradigm, right? So in that case, I can create my own microservice and then I can work on that independently. Okay, some later point of time, if people need that bidirectional streaming, then they can look into the bidirectional streaming. If a community needs only that sequential or just only care about or one about the final, then still they can use the command executor. That's the reason it created a way for Pi executor, and then Pi executor it doesn't use a separate API, separate proto. Okay, it shares the same proto whatever CDS uses that. Okay, CDS uses the proto of a process. Okay, that same it uses the same. So it means like the Pi executor uses the same definitions what CDS exposes. So in that case, tomorrow for a certain invocations, you have only the Python execution or you have only the Python scripts. I assume that I think that I don't want to involve a CDS in between that. So in that case, SO can directly talk to Pi executor just by saying that blueprint name and versions and then what action that I need to perform. So in that case, we can completely skip the CDS environment itself. So directly with that Python scripts, then I can call from either from CDS or from any external system, or I can provide any functionality where this CDS platform can support for anywhere. Okay, not only in the CDS space, so it can involve in anywhere where Python is a core capability. I believe I put a lot of concepts here. Just I pass it here to take some questions or take some. Yeah.
Yes, sure, Bunda. Now it's clear, but I guess there is a plan to move like maybe command executor into Python executor to have just one Python environment remote execution. So that would be kind
Exactly.
of yeah, I understand.
Yeah, in this case, we are not saying that deprecation of that command executor. Okay, it is up to you because it's a microservice. You can design which one you want to go. But if you go with that Py executor, you will get a streaming response. Okay, and another important constraints also that I have with the command executor. What's the command executor? It's like command executor creates the runtime during that invocation. So that is the reason sometimes it may need some heat up time. So it means like it wants to download some pip modules from the pip packaging repository and tries to install that. So certain organization like AT&T, we completely restrict that installing of software or using the software during that dynamic runtime. Okay, so because that particular versions may not be tested, as we all know that, right? How the pip works. Okay, that package dependencies, it is a little bit complex. We can't assure that whatever the dependent module versions, okay, tied with that, okay, we can't assure that. So that is the reason. Sometimes what's the thing is, we want to make sure that what are all the third party packages we are trying to use, that should be tested at least once in an environment, once in a test environment, and those and the particular same instance of that environment going to use it in the production. So that's the reason it's a slight difference between command executor and Py executor. As I mentioned that Py executor, you can create a number of images based on that based on that requirements. So if you look into the Py executor, it has that requirement text file. So only thing is you can clone a particular project inside your organization for X functionality, and then include only the packages that you need here. Okay, sometimes I may need an NC client, sometimes I may not need an NC client, so that this container is specific to that particular functionality and particular scripting capability. Yeah, that's all I have with respect to the difference between a command executor and Py executor. And then finally, we are not going to deprecate the command executor, okay, just for the note.
Question, Brenda, and the only thing that I see is missing is all the utility class and object that we created around Jython. That
exactly.
is not, we don't have any implementation from command executor and Py executor right now. So if I need that capability, for instance, I need to do some resource resolution using a Python script, then if Jython is not there, I cannot do it. I either need to use Kotlin or use the command executor, but then I don't have the utility to do that. Or if I need to resolve, to retrieve a resolve template, which was very easy using the resolution helper class in Jython. Using so what's the, because
let me explain. Okay, so we have a
okay.
Let me explain that another important concept called extension function, and then I will come to your solution also. Okay, it's a little bit elaborate. It's okay, or I want to reduce the talk. And just I need a feedback from the team, right? How I want to go. It should be elaborate session, or it should be
yeah,
I think
so my thing, I mean, the same question asked already. I mean, this is the same question as from me. So just list. So these utility functions are just dropped. So is there a way to do it other way?
Yeah, exactly. There is a way. That's the reason I want to make sure that everyone, you are having a time to sit for some more time. It's like another 30 minutes, so that I can explain the complete concept of how we want to do, or I want to reduce the talk and then spend the time. That's the point I'm trying to make.
I think maybe we're going to need another session because I think we're running out of time, and I think it seems like it's getting some traction. And I think internally at Bell, we mainly use Jython right now because of those utility. So if we drop that utility, then it could be a big deal for us. So let's maybe do it next time or schedule a specific meeting for that.
Sure, definitely. Okay, so I have a 10 minutes. So meanwhile, if you have any questions, then we can discuss or any other topic. Okay, little bit I will continue that, and then let's see, okay, how far it goes. Yeah, so we have extension functions. Let me talk about that a little bit about the extensions functions. Okay, so the extensions functions.
Before you continue, can I just make sure I understood correctly the difference between command executor and py executor? Is that in py executor, we will not be able to do pep install because we're going to need to package image with the proper dependency, because for you in AT&T, you kind of need to use dependency to be tested inside the development environment and not installed as is, right? Is that
Exactly.
That's correct? Okay.
Exactly. And another important thing, it's like it's streaming. Okay, if you try to look into that, it is a streaming, so that you can send back that notification, send back the logs, okay, and even server and client can talk to each other. Okay.
I got that point. Thank you. Yeah, thank you.
Okay. Next, coming back to that, another important functionality called extension function. Okay, let me explain the extension function a little bit. So each function, okay, ultimately how the CDS, it's a plug and play framework. So it means like you don't want to develop your own functions inside the one app. You can develop your own functions inside your organization and just expose as an extension function, so that your scripting can use that, so that your scripting can be organization specific. In that case, you don't want to bring and develop everything or your secret sauce inside this one app. So you can. So only the reusable functionality, such as a netconf invocation, netconf API, resource resolution, and then REST invocations and all DB libraries, only that kind of stuff that we are going to develop as a functions in the one app. One good example, let me talk about the resource resolution, because we are more interested on resource resolution. So each module has its one file called extensions. Okay, so that is a pattern that we try to follow. Each function has that extension. So it means like each function extension, it tries to expose a certain services to a script framework. Okay, so how we are exposing to the script framework, as I explained that the scripting pattern here, it's uniform throughout the series. So it should always extend abstract the script function, script functions, script component functions, I believe. That is only one package, irrespective of anything. Okay, only the resource resolution capability is going to extend a different name or different package. But other than that, all the component functions that we are going to implement, it is going to implement with a single function, single class, I could say. And so if you try to look into that particular function, okay, so this is that parent node. If you are trying to implement as a capability or capability function, then you can extend as an abstract component node, so that it can be modeled as a node template, a node type, and you can create a node template out of that. If you are trying to model as a script, then you can have you want to extend this abstract script function, which provides a certain difference. Okay, there is a difference between abstract component function and script function. This is mainly used for script. Okay, so the parameter, that what I'm trying to say here, it's like, so the parameters for this script component function, it's a component function. So this is a component function. So it means like if I attach any function to this component function, then it is applicable for a component, and as well as it is applicable for script. So the Kotlin provides a very good functionality called extension function. So in that case, I can write any extension function, okay, or I can create any function or any utility, okay, with respect to the particular function, and then I can attach that function to a abstract component function, so that in that case I can directly use this component resolve artifact NP directly inside our script. Okay, this point is clear. I think stop me if you don't understand this concept of called extension function. So what are the functions you are trying to create, or what are the capabilities you want to provide, inject in the scripting? Why we are going for a scripting? The scripting should be very simple, and it should be easily understandable, and it should abstract most of the complexity. So that's where, because scripting mostly it's going to involve mostly going to develop by network engineers or VNF owners, so they don't want to understand that complexity and coding style under beneath that. Only thing is they want to understand what API that I want to use. That's the only thing we are going to, or it should be very simple. So that's the reason you can design your components, okay, or a component API in a simpler way, and just expose to that particular script and component, so that anybody can use it very effectively by just understanding by reading the documentation itself. Okay, so this provides that component resource. So in that case, now it is applicable for any of the frame or any of the scripting framework. Even it is applicable for Jython, even it is applicable for Kotlin. But only the difference between Kotlin and Jython, it's like if you are developing a script, then easily you could get a content assist very easily, okay? Because IntelliJ provides a content assist very easily, so that if you are trying to create a Kotlin script, it automatically tells that there is a component functions already available whenever you go and type inside a particular script implementation. So in that case, you don't need any wrapper function there. So you can simply directly write the functions and then play with our APIs and to understand that what is input and what is output. You can easily play with it. The problem with the Jython is like Jython doesn't understand the component function. Okay, what are the functions available just for usability perspective. So in that case, that is the reason we are coming up with that wrappers, right? So wrappers are nothing but it is going to wrap this particular API exposed by that Kotlin. So it means like if we are having a wrapper function, then definitely there is a Kotlin function underneath that. Okay, one good example. Let me show what are all the wrapper functions we have. The wrapper functions we have it under component scripts mostly. Here we have it the wrapper function. Okay, it's one high level wrapper function. It's like a netconf. Okay, let me take one netconf wrapper function. So yeah, this is a wrapper function, right? So this is where it's like a bell or mostly the inside the netconf Python-based netconf scripts uses that. If you try to look into that, the top level, it uses a netconf executor extension, right? You could see that extension. So it means like whatever the extensions that we are trying to provide in this class, it is trying to use, and underneath that, it is going to use that same, and then it is going to try to use the same class implementation. So if you try to look into that, so in this case it is a different wrapper function. Just let me talk about this one, self.nc client. Okay, so that where exactly, yeah, see here under that netconf, we used to resolve a resource and then we need to perform that image or perform the configuration on the device. So in that case, we want to use a resource resolution function here. So just I'm switching from netconf to resource resolution. If you try to look into that, resource resolution function uses that resource resolution extensions and the same. So inside the Python wrapper, we are not going to have any information other than that just wrapper call. Okay, just so that that Jython module for content assist perspective, we can easily look this particular API and then we can make a call. Now finally, end of the day, this has a one-to-one mapping. You could see that it has a one-to-one mapping altogether. All the APIs, whatever we have written, it's like a one-to-one mapping. So netconf, resconf, even resource resolutions, all performs in the same way. So it means like what are the Python packages that we use? Okay, it is underlying. It's provided by the Kotlin. Okay, Kotlin extension function. So the matter of converting from Jython to Python, it's simple just by changing that Kotlin extension. Okay, it's a Kotlin extensions and using that extensions function directly instead of that wrapper. That is the point I'm trying to make. Okay, so it means like we can use directly the Kotlin functions. Okay, just by instead of just by referring that particular wrapper function, you can use this common function as it is. That's all. It's a mere change with respect to Jython to Kotlin if it works inside the runtime of CDS. And for Py executor and Python executor or command executor, I will talk in the next session how we want to work and what are the efforts and what are the work items that we want to put into that. Okay, I pass here. Just I can
yes.
take a fire.
Yes, Bernard, just to complete what you were saying about wrapper function, there are many functions that we need to add again. So I create a patch to complete that. So I'm working on have a complete wrapper function for all the extend function that you are mentioned. Just
exactly.
to yeah.
But really speaking, what is my suggestion? I could say it's like instead of working on wrapper functions, you can write as a Kotlin file or Kotlin script itself, so that you can use the extension function directly, so that you don't want to waste waste in effort of creating a wrapper functions which we may not use it in future.
So maybe I missed some point,
guys.
because these wrapper functions are Python, but you cannot run Python anymore inside the CDS. So where you run these wrappers?
Wrappers it is not going to use, right? If you are not going to run a Python inside CDS or Jython, okay? Just be careful. Just follow the word Jython, okay? If you are not going to run a Jython
not
inside the
Jython.
CDS, then this wrapper function is useless.
So why do mention this? Because this is removed.
This is remote. Just for how it is working, just I'm explaining how it is working now.
Yeah, but okay. Just
We-
interesting that the routing
We
is
still
done.
haven't
Guys,
touched.
we should be moving away from Jython and Kotlin running within the same
Yeah, Jython is gone.
and just moving to executors, whether that's a Python executor or Kotlin executor.
Yeah, Jython is gone. We're interested only what is left. So and
Yeah,
how to
actually,
replace it? How to replace it?
yeah.
I think Breda just explained the current mode of operation, and then maybe next session is going to explain how to resolve those feature gap with the new PY executor. I suppose, correct, Breda?
Yeah, exactly.
Okay.
So one way it's like converting to Kotlin. That is what I'm trying to explain. Okay, so it means like instead of using your Python, Jython implementation, assume that in a Jython you use a edit config. So instead of Jython's edit config, move that Jython file to Python, Kotlin file, and use that wrapper function. Instead of using a wrapper function, you can use that extension function directly. You're getting my point. You're following my points.
Yeah,
Yeah.
sure.
Yeah, Bunda.
Okay. Yeah. So in that case, my suggestion is like don't put effort on creating a wrapper function, because we are not going to use anyway. So instead of that, try to use the Kotlin function directly as a Kotlin file.
Got it.
Okay, that's all I have for now. So we can talk later. Any other questions that we want to bring up?
I'm good for now.
Sure, thank you.
Thanks you
Thank you.
for the explanation, Breda. It was very
Thank you.
insightful.
Yeah. Thanks a lot.
Thank you.